1.
Hi guys, today we are talking about radian measure. So this is our first note as we're going into trigonometry. So in grade 11, we talked about the degrees. So we looked around a unit circle, which is something like this, okay? And as you go around the circle, you look at the different degrees as you go around the unit circle. So degrees in this direction are positive, okay, and degrees in this direction are negative. So you always start here where the positive x-axis would be, and you come up with your angles that way. However, in higher level mathematics and things like physics, they don't actually use degrees anymore. They use something called radians. So think about it like converting inches to centimeters, okay? So in the United States, they use inches, and in Canada, we use centimeters. And you can think about certain things in your life where maybe you might refer to it in centimeters, and certain things where you might refer to it in inches just because you're used to it or it makes more sense to you. Just like some of us with our temperatures, especially living in Southern Ontario, there's certain temperatures where Fahrenheit makes more sense to us and certain temperatures where Celsius makes more sense to us. So this is the same thing with degrees and radians. The numbers look completely different, but they're both referring to the size of an angle, okay? So in math and physics, let's go through this note now. In math and physics, it is often more useful to express an angle without units, so without degrees. The size of an angle in this case is expressed in an angle in terms of an arc, which we call A, that subtends the angle theta at the center of a circle with radius r. This is called a radian. So I know you guys are like, say what now? So we're going to go through this together, okay? So this is the arc here. So if this is the angle theta, okay, so it starts here and goes in this direction, okay, so we'll call that theta. Okay, the arc that subtends the angle is this arc here. So the curvy part of the circle. So this is A. All right, the radian is here. And here, sorry, not the radian, the radius. Oh my goodness, the radius. So that's the radius r, and this is also r. So theta is equal to 1 radian. That should say 1 radian, when the length of the arc, so A, is equal to the length of the radius. So when the length of this arc is the same as the radius of the circle, then theta has gone through 1 radian. Okay, so it appears that 1 radian is approximately 60 degrees because this segment here would represent or resemble an equilateral triangle, since this is the radius and this is the radius and this arc is the same as the radius, and so if it were a triangle it would be equilateral. So that's interesting, but it's not exactly 60 degrees. So if we know degrees, how can we change it to radians is our question. So we're going to develop that right now. So imagine that we have an arc that subtends all 360 degrees of a circle. Okay, so, oh, I forgot a section up here. So theta, okay, because theta is equal to the ratio of the arc length divided by the radius, okay? So theta in radians is equal to the arc length divided by the radius, okay? So this is just the definition, part of the definition of how to define theta in radians, okay? So that's important. So if we're looking at all 360 degrees of a circle, we have to think about what would the arc length be and what would the radius be. Well, the radius is the distance from the center of the circle to any one point. So that's r. Okay, and then if we're going all the way around the circle, all 360 degrees, So theta equals 360 degrees, but we're trying to figure out what that is in radians. Think about how long the arc would be that subtends that angle. The arc would actually be the circumference of the entire circle. Okay, so the arc length, when you go all the way around, is actually the circumference, which we know is equal to 2 pi r. Okay, so therefore, theta is equal to the length of the arc divided by the radius, so 2 pi r divided by r. And now you can cancel out these r's, and you're left with 2 pi. So that means that the size of angle theta is 2 pi radians when you go all the way around the circle. So that means if we're comparing degrees to radians, so an equal number of degrees to an equal number of radians, 360 degrees is the same as 2 pi radians. Okay, so therefore pi is actually equal to 180 degrees. So you'll notice that when we're talking about the size of angle in radians, often we have pi as part of the number. And pi is just the same as 180 degrees. So when we learn how to convert here, okay, you've got to remember that pi is just equal to 180 degrees, okay? Or the whole circle is 2 pi radians. Okay, so if you know your radians and you want to switch it 2 degrees, if the radians are written with pi in there, all you have to do is replace the pi with 180 and multiply it through, and voila, you have your degrees. Okay, but if it's written in terms of like a decimal, like 1.17, then you just multiply it by 180 degrees divided by pi, and you'll have your degrees. Now, if you're given your degrees and you want to express it in radians, you multiply it by pi over 180, okay? And then you simplify that fraction. Okay, another way of doing it is by inspecting a unit circle. So for example, if you say like how many degrees, if you have 90 degrees, what is that in radians? Well, if you think about that on a unit circle, you can just say, well, theta is a quarter of a circle, and I know that the whole circle is 2 pi, so that simplifies to 2 pi over 4, which simplifies to pi over 2. So 90 degrees is the same as pi over 2 radians. Well, what if we had theta equals something that's not so obvious, like something like 210 degrees? Well, think about where this is on the unit circle. So you go around here to 180, okay, and then you go a little bit further to 210. So you can break it up. This much is 180. And then how much do you have left over? After 180, you have another 30 to get to 210 altogether. So the 180 is actually half a circle. So that is half of 2 pi, so pi. Or you can just use the fact that you know 180 is pi. But what about this 30? Well, that is, how much of a circle is that? 30 over 360. What percent of that is, what is that? So if you put that into lowest terms, that is 1/12 of a circle. Okay, so therefore my theta is going to be just 1/12 of 2 pi, which is 2 pi over 12, so pi over 6. Okay, so my whole angle then, 210, is just my pi plus my pi over 6, right? My 180 degrees plus my 30 degrees. So if you put that with a common denominator of 6, you get 6 pi over 6 plus pi over 6. So you get 7 pi over 6. So 210 degrees is 7 pi over 6 radians. Okay, so I did that by inspecting the circle and thinking about what proportion of the circle did it fill. You could also just take your degrees and multiply it by pi over 180 and get the same result, 7 pi over 6, right? You would just get 210 times pi over 180 and reduce 210 and 180 to 7 over 6, you get 7 over 6 pi. So here's a few more examples here. Convert 225 degrees to radians. So this is degrees to radians. So we take our 225 and we multiply it by pi over 180. And so think about it. These units, the degrees cancel out. So we're left with no units, which is what we want. Okay, so we get 225 over 180 pi. So you have to put that fraction in lowest terms. So you get 5 pi over 4. Okay, so wherever possible, you want to leave it where the pi is included. You don't want to turn it into a decimal. Okay, convert 5 pi over 6 to degrees. So this is a good case because you already have a pi in there. So all you have to do is just replace pi with 180 degrees. So 5 times 180 degrees divided by 6. So that equals 150 degrees. Okay, here's a case though where we have radians and we're not able to put it into degrees by replacing pi because there is no pi. So we just have to take our 1.75 and multiply it by 180 over pi degrees over pi. Okay, so these radians will cross off. Okay, so when you do this, you get 100.3 degrees, so just over 100 degrees. Okay, so that's one type of question. You're going to be asked to convert degrees to radians and radians to degrees, going both ways. You'll also be asked questions where you're asked to use the definition of a radian to think about the length of an arc. Okay, so remember that theta equals a over r. So when we talk about angular velocity, this comes into play. So the London Eye Ferris wheel has a diameter of 135 meters. Okay, so you can make a little picture. The diameter is 135, so that means the radius is half of that. It completes one revolution in 30 minutes. So I just like to picture the circle there, whether you label it or not. So determine the angular velocity in radians per second. So this means the angles traveled per second, and they want it in radians, not in degrees. So you have to think about, well, you know that it takes one revolution in 30 minutes. So one revolution is 2 pi radians per 30 minutes. So that means that you have 2 pi over 1800 seconds, because notice it said per second. So then you just put that into lowest terms, which is pi over 900 radians per second. All right. The next question says, how far has the rider traveled in 10 minutes on the ride? Okay, well, 10 minutes, notice 10 minutes, that's 1/3 of a complete circle. Okay, so that's what's important to note, is that it takes 30 minutes to do it all the way. So how far has it gone in 1/3 of that time? So therefore, the entire wheel, so if you think about your circle here, okay, and you started here, 10 seconds, 1/3 of that is probably about there. So they want to know how far the riders traveled. So they want to know the length of this arc, basically. So remember that theta is equal to A over R. Okay, so the entire wheel is going to be equal to, if you're looking at the entire wheel, your theta is 2 pi, which is equal to your arc length divided by your radius, which is 67.5, which is half of 135. So therefore, the arc length of the entire thing is 135 pi. All right? So therefore, the arc length here that we want to know would just be 1/3 of 135 pi, which equals 45 pi. Okay, and if you put this, 45 pi meters, or in decimals, 141.4 meters. So you can write a nice little therefore sentence with that. Okay, or, I mean, you can just find the circumference of the circle using pi d and just do 1/3 of that. That also will give you 141.4 meters. Okay, Susie rides a camel 9 meters from the center of a carousel. Okay, so imagine here's the carousel and here's Susie. Okay, she is 9 meters away from the center. Okay, so in other words, the radius is 9. If the carousel moves through an angle of 5 pi over 6, how far has the camel moved? So think about it. 5 pi over 6, that's just less than 6 pi over 6. So that's just less than a pi, so it's just under 180 degrees. So we would end up something like here. So here's where Susie starts, I'll call it S1. And here's where Susie ends, I'll call it S2. And they want to know this arc length. Boop. Well, again, we can just use that arc length is equal to, I should say that theta is equal to arc length over radius. So we know that our theta is 5 pi over 6. Okay, this here, she's gone through 5 pi over 6. And our arc length is what we're solving for. And our radius, that's an A. Because our radius is 9. You got to make sure those look different. Sorry about that, guys. So if you solve for A, you get 45 pi over 6 is equal to A. So therefore, A is equal to 23.6 meters when you put that into meters. And then you can do a sentence. All right, one last question, and then we'll wrap up. The angular velocity of a rotating object is the rate at which the central arm rotates with respect to time. A hard disk rotates at 7,200 rotations per minute. Determine the angular velocity in radians per second. So we have 7,200 RPM times 2, you go through 2 pi every revolution. Okay, so basically that just means you have 14,400 pi angles that they're going through every minute. Okay, so then you just have to convert that into seconds. So if you do this many every minute, to find how many you do per second, you just divide this number by 60. And you get 240 pi radians per second. Okay, so you kind of just got to think about that logically. Okay, if it's going 7,200 times a minute, it's 2 pi every time. So you get this many radians per minute divided by 60 to figure out how many per second. Okay, just a few final tips. Whenever an angle is expressed with no unit, you have to understand that it's in radians. We write the word radians to remind us that the number represents an angle, but otherwise it's not actually necessary. Remember, if you're finding an angle in this direction, that would be a positive. And remember, if you're finding the size of an angle in this direction, so going clockwise, that would be negative. Okay, so thanks for watching, guys. I hope you learned about radians, the definition of a radian, how to convert between radians and degrees, as well as using your knowledge of radians to solve problems. Thanks for watching. I hope you learned a lot.